Hello everyone and welcome to this my video on binary permutation and communication matrices. My name is Darren from Maffs Guru. Thank you so much for watching. If you are new to this, please do me a massive favour and subscribe. Subscribe to what? My YouTube channel, of course. Why? Who watches maths videos? The fact you found this, greatly appreciated. Hopefully you stick with it to the end and learn something. Very few people watch, and every time someone clicks that little subscribe button, I get the greatest buzz. I know that sounds ridiculous, doesn't it? You really? But actually, there are many days I want to give up doing this because it's hard work sitting on here talking to myself and the dog. I'm going slightly mad, but every time at the end of the day I look at how many people who have subscribed, every time that number gets to 3, I literally run around my house and go, yay, 3 more people. Anyway, what am I going to talk about this lesson? Well, goodness gracious me, you guys can read. So if you want to, pause the video there and read it. There are lesson notes downloadable from mathsguru.com. So if you're watching this and you want to download the stuff and put it into your summary book, it is there for you. And this video is relevant, not just outside Australia, but all over the world. Right, should we get on with it? I think so too. In previous videos, yes, you've watched the previous videos on mathsguru.com, haven't you? Please tell me you watched the video on mathsguru. Oh, come on. There. But we've looked at adding matrices, subtracting matrices, multiplying matrices, and inverse matrices. And the inverse ones are the really important one. That was my previous video, and probably one of my best ones today, he says. Now let's look on what a binary matrix is, because I'm going to build into something that we're going to deal with permutation matrices and communication matrices in just a moment. But a binary matrix is basically a number system which uses, or binary is a number system that only uses ones and zeros. Okay. So pretty much everything you store on your phone, your computer, in your credit cards and whatever else is a series of ones and zeros, generally stored in a matrix, right? Or stored in a way that your computer can read them. So a binary matrix then, it makes sense, is a matrix of any size. It doesn't have to be square, which is populated by ones and zeros. So these are fabulous examples, if I do say myself, of binary matrices. There is a row binary matrix, there is a 2 by 2 binary matrix, a column binary matrix, a 3 by 3 binary matrix, and you could go on forever, but I won't. So long as it's got ones and zeros in it, that is fine. This one here is a special type of binary matrix that we're going to come to in just a second, because what you'll notice is that every row and every column only has one 1 in it, all right? So we've got a 1 in that row and column, we've got a 1 in that row and column, and a 1 in that row and column, and that's actually massively important. Why? Because we're going to come to permutation matrices, and that is effectively what we call a permutation matrix. You're going to go, what on earth is a permutation matrix? Well, what it is a way to permute something, i.e. change it around. So if I was going to give you my name, Darren, I'm sorry, I won't give you my name, Darren. It's mine. You can't have it. But if I was going to have my name, Darren, and ask you to write it in a different way, then we could have, as I said there, Nerad, which is awkward. And if anybody ever sees me on the train and goes, yo, Nerad, I will cry. What else could we have? We could have R-A-D-R-E-N, Radwan, and so it could go on. There are so many different ways we could write the letters of my name, and I'm not going to do all of them in this video because we could be here forever. And I'm never going to get subscribers that way. But what if there was a particular way I wanted to permutate it? What if I wanted to do it in a particular pattern? If I wanted to move the last letter to the first every single time and just keep cycling through it? All right, well, we can probably do that. But there's one thing we need to know as well with the language. If we learn anything from general maths, it's the language here tricks people, yes? And the idea that the words pre and post, yes, now when I worked in a bar, post-mix was effectively what you put into your Coke on top of the soda, but that's again a different matter altogether. I don't know why that was relevant, we just threw that one out there, but pre means before. So if I was going to have 2 matrices and I multiply them together, in that situation, B is being pre-multiplied by A, before. In this situation, if I had B times A, B is being post multiplied by A. Okay, silly, but you never know whether they're going to throw that into an exam. So here we go. Here's an example, and I want to see what happened. X is the column matrix TAR. Oh, we've got letters in this one. P is the permutation matrix 0, 0, 1, 0, 1, 0, 1, 1, 0. And again, what is important to notice there is that the rows and columns, There's only one 1 in each row and each column. They're not overlapping. If that was a 1 there, then this would not be a permutation matrix. That would trick you, all right? Show that. Now, obviously, show that is awesome. Pre-multiplying. Now, don't worry about that little floaty 2. I've taken this from the Cambridge textbook. Thank you, Cambridge, for allowing me to use your examples. You guys literally rock. Thank you. That's basically, there's a little note in the textbook down there that says, this is what pre-multiply means. It doesn't mean pre-multiplying squared. That makes no sense. Pre-multiplying x by p. All right, so pre-multiplying x by p means we're going to do p times x. Changes the matrix to matrix y, RAT. Right, I'm going to do it by hand first. So we're going to do 0, 0, 1, 0, 1, 0, and 1, 0, 0. And that's my p. I'm going to now multiply that by x, which is t, a, and then r. Equals. Now, believe it or not, yes, we can actually do this with letters. Don't get hung up on the fact that we've got letters. So how do we multiply? You do row by column. So we're going to do the 0 times the t goes, 0 times a goes, 1 times r means let's keep the r. So that now becomes r. Hold on a moment. That's pretty awesome. That 1 there has moved my r to the top. Ooh, it's permuted. I wonder what happens next. Right, well, what we're going to do is this row times that one. So the 0 times the t, well, 0 times anything goes. 1 times a gives me a, and 0 times r goes. So in which case, my a stays exactly where it is. Huh, interesting. And what about this one? That times that. So 1 times t gives me t, 0 times a, 0 times r goes. So in which case, this here is going to become t. So this matrix here has funkily changed the letters from TAR to RAT. Mind blown. Pre-multiply x by p squared, so show that it leaves the matrix x unchanged. All right, so when you've got p squared, what that is effectively saying is multiply your result by p again. So what I would now be doing is 0, 0, 1, 0, 1, 0, 1, 0, 0, and let's multiply that by RAT, which gives me, and believe it or not, well, I'm actually going to show you how to do this on your